Hey everyone, my name is Harmon. I'm the chief machinist at Taormina Racing. Our company is currently in the process of trying to remanufacture the air-cooled Porsche 911 engine cases. When trying to machine something that's going to be housing a rotating assembly, producing power, this requires a lot of accuracy and precision. In this particular case, I want to talk about the intermediate shaft bore. Now this feature is an 8-inch deep feature with a diameter of about 1 inch and a tolerance of plus or minus 0.0004 inches. To put that in perspective, a human hair is approximately 0.003 inches, so we need to be about 10 times more precise than that. Now, in an effort to solve this problem, I came across a company called NT Tool Corporation. They're a Japanese company and they provide tooling and tool holding solutions for the major automotive manufacturers there. Today I want to do a review on the zero runout tool holder and whether it's going to solve my problem or not. Let's take a look. Now before I get to the zero runout tool holder, let me just show you the original setup. What we had originally planned was to have a custom reamer made so we could just chuck it up, create the pilot hole, and have a finished bore to the nominal dimension. Now the problem is when we received the custom reamer, we went to chuck it up in a typical an ER40 collet tool holder. And let me just show you what the problems were with that. Now that I have my dial indicator set up, let's just take a look at the runout of about an 8-inch long tool in a Cat 40 ER40 holder. Now, as you can see, the runout that I get with this setup is about 4 or 5 thou. With a bore that requires such a high degree of precision, a 5 thou runout it's just going to make my bore overblown. It's going to be too big. Let's take a look at the zero runout holder and let's see how close we can actually get it to zero after we do the adjustments. So here's what it looks like. It's a bit bulkier than most of the collet-based holders that I have. What you do is you insert your tool in that area, you insert your spanner and tighten it in this area, and then you have 4 points of adjustment here. Now there's a little set screw in 90-degree increments around this tool. And what you do is you put in your tool and depending on the runout, you will tighten up or loosen up these set screws in order to basically push on the tool and bring that runout in as close to zero as possible. Now let me put in the reamer, install it into the machine, set up my dial indicator, and we'll see what this tool holder can do. So here I've installed the zero runout holder and reamer into the machine. I haven't adjusted it yet. Let's just check what the runout is before adjustment. So without even adjusting it, we got a run out of about 3 thou. It's pretty good. Let's see what we get after the adjustment. So I just spent about 10 or 20 minutes making the adjustment. Came out pretty good. Take a look at the results. So I finished the adjustment, measured the run out before and after, and measured the run out on a typical ER collet style tool holder. The results were excellent. Basically, we went from 4 or 5 thou from a typical ER collet holder to about 2 or 3 thou on the zero run out holder without any adjustments. And after making the adjustments, I was able to get the run out to within 2/10. I mean, I would say this is excellent. Shout out to Stuart from NT Tool USA. I'm looking really forward to using this tool. I expect excellent results. With a 2/10 run out, that really puts us in a good position to make that intermediate bore to the nominal spec within tolerance, and eventually it'll give us an excellent running, high revving, power producing engine crankcase. So again, thanks for checking in. Thanks for watching the review. If you're in the States and you're a machinist and you're having trouble creating accurate deep bores, definitely give NT Tool Corporation a call. Excellent people. They really helped me out. Thanks again. See you next time.